Welcome back, Matt 2. Today we are going to discuss similarity and the relationships between it in area and volume. Now, we already talked about what happens to the similarity ratio when we move from sides to areas, and we'll hit that again. And today we're also going to discuss what happens when we include volume. All right? So let's fill in some blanks here. So when two shapes are similar, their sides are similar as well, with the scale factor. Okay. Their areas will also be similar, but with the scale factor squared. Okay. So remember, we talked about that yesterday, how going from one side to another is one dimension. But then if we add in area, we're moving into two dimensions. So all of a sudden we have to use not just, let's say, a scale factor of 3, but a scale factor of 3 squared, which is 9 for area. Okay? So let's practice that idea again real quick here. So I have these two rectangles. And first thing is they asked me for the area. So remember, area of a rectangle is just length times width. So my first one, 3 times 9 is 27. And my small one, 1 times 3 is 3. And then it asks for the side scale factor. How am I getting from one side to the next? Okay. So my scale factor for my sides, if I'm going from the big one to the small one, is actually 1/3, or I'm dividing by 3. The way you could test that is to put the smaller, or to put the new shape over the old shape. So 3/9 is 1/3. So then the scale factor for their areas would be that 1/3 squared, which, remember, if we distribute this exponent of 2, it's going to give us 1 squared over 3 squared, which is 1/9. Okay. There is also a relationship between the scale factor in volume. Okay. Now volume, let's see if you can take a guess here. So with area, we added a side, a dimension, so we started squaring it. This time we're adding another dimension, so we're in 3D now. So we're going to have to multiply again. So volumes are also similar, but with the scale factor cubed to the 3rd power. Okay, so for example, I have some rectangular prisms. I can find the volume by doing length times width times height. So first off, let's just get that side scale factor. Okay, so on my long side, I'm going from 2 to 4. So that is a scale factor of 2. I'm multiplying by 2. Okay, so the volume scale factor should be 2 to the 3rd power, or 8. There should be a change of times 8 in the volumes, and let's test that out. So in my first one, if I take my volume and I do 1 times 1 times 2, that'll give me a volume of 2. So if I take 2 times 8, I should get 16 for this volume, but let's test it out. So I'm going to have 2 times 2 times 4. 2 times 2 is 4. And times that 4 is 16. Okay, so even though I'm only doubling the side, that means I'm taking the entire inside of this shape and multiplying it by 8. Okay, because I'm working in 3 dimensions. There are 3 different sides that are getting multiplied. Okay. So let's talk about how we switch between all of this, okay? Because sometimes you're given surface area and you need volume. Sometimes you're given volume and you need a side. So let's talk about how we go from different things, amongst different things, okay? So the easiest one is if you are given sides and you need surface area, or area, okay? Given sides and need surface area. what you want to do is you want to find the scale factor. Remember, that's always related to sides. And then you want to square it. Okay. If you need to go the other way, you are given area and you need sides. Okay. You have to do the opposite. So the opposite of squaring something is square rooting it. Okay. So you want to square root whatever the area scale factor is. Okay. So square root the area scale factor to get the side scale factor. What about if we have volume? Okay. Again, going from sides to volume is going to be a little easier. So if you have sides and you need volume, you're going to take the side scale factor and cube it, which will equal your volume. Oops. If you have it the other way, where you have volume, but you need sides, there is actually such a thing as a cube root. And I will probably have to show you where this button is on your calculator. But you're going to take the volume scale factor and you are going to cube root it. Sorry, cube is not spelled with an R. And that will give you the side scale factor. The only one that I didn't write on here that if you have some room, make a little bit of space for, is if you have either volume or area and you need to get to the other one. So if you have volume and you need to get to area, or if you have area and you need to get to volume. Okay, the process for this is that you have to go back to sides first. Okay, so if you have volume and you need to get all the way to area, what you really need to do is say, okay, I'm going to go from volume to sides, and then I will go from sides to area. Okay, so remember, volume to sides includes cube rooting, and then going from sides to area, and then going from sides to, sorry, I don't need that. Going from sides to area involves taking that scale factor and squaring it. Okay. It's the same idea with area to volume. Okay. So if I need area, or if I have area and I need volume, I got to start with area and go back to sides and then use that to go back to volume. Okay. So to go from area to sides, I'm going to square root the scale factor. And then to go from sides to volume, I take the scale factor and I cube it.